Okay, so this is the full version of IFTT-PIN with a full self-calibrating implementation. And it's the same as the interface before, the same principle. We want to type a 4-digit PIN on top. The square one indicates the one we're currently typing. And the digits have colors on them, yellow or gray. And we'll use the same principle. We'll type, if let's say we want to type a 2, we'll click on the yellow button, but as you can see, there is no yellow button. And the particularity is that the yellow button is only in our mind. We decide which button we want to be yellow and which button we want to be gray. So to make things transparent and easy to follow, I'm going to show you what's in my mind right now. What's in my mind right now is I want to type the digit 2. So that's where I am looking. I'm looking at 2. And in my mind, I decided, and that's a decision I made, I decided to use the buttons the way you see them. So kind of a gray cross and yellow in the 4 left position. So let's start. So I'm looking at 2. 2 is yellow. So I'm going to use this yellow button. So I just clicked the yellow. Nobody knows it, just me and you. 2 is gray. I'm going to click the gray button. 2 is yellow. I'm going to click this gray button, this yellow button this time. 2 is yellow. I'm going to reuse this button. I'm just going to use this line to make things a bit faster. The middle one is gray. The middle one is gray, and 2 is gray. That's it. After a few clicks, we figured out that I was trying to type a 2, which is fair enough, because that's what I was doing, and that I was using those buttons in that way. Obviously, all the buttons I have not clicked on, the machine cannot know what they mean, and actually I could change my mind again and redefine them if I wanted to. For now, I will just keep doing the same task again and reusing those buttons just to show you that it's faster, and then I will start reusing the one above. So if I want to type a 2 again, let's skip 2 so it's easier, and I do yellow, gray, gray. And that is much faster than we did on the first time. Why? Because the buttons are already calibrated. I already know, the machine already knows that I've been using them for yellow and gray. And because this is the same experiment, we simply assume for this case that the user is using the button the same way for its digit. Now let's say I want to type 2 again, but I will continue now using other button that I've not clicked yet. So 2 is yellow. I'm going to do yellow, gray, yellow, gray, gray, yellow, gray. I'm using all the buttons, which makes it a bit slower, because when we click on a button that's never been clicked before, we don't really gain that much information, which we will see in the other, like the demo with the side panel. 2 is gray, 2 is yellow. That's it. Again, I've typed a 2, which is what I wanted to do, and now we have the full pattern that it revealed. If I type another 2, that time all the buttons are defined, so it will be really fast. That's it. I just typed 4 2s using that pattern. Just to make sure you understand that I'm not cheating here, first you really want to do this at home, so you get the hang of the problem, but I also want to show you that the same interface, the exact same thing, I've not changed, I've just reloaded the page, not changed anything further than that. And this time I'm going to type an 8, and I'm going to use a different pattern. So both my intention and my action to meaning mapping has changed, and the machine doesn't know that. So I'm looking at 8. 8 is gray, and I'm going to click on this gray button. 8 is gray, so I'm clicking on this gray button. 8 is yellow, so I'm going to click on this yellow button. Yellow, gray, yellow, yellow. That's it. After a few clicks, we identified 8 and a subpart of the button colors. I will keep typing an 8 using this map, and from time to time reusing some button. I'm just going to be really flexible on that. So yellow, gray, yellow, gray. Another 8. 8 is gray, 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 yellow, yellow. And that's it. We have the whole map covered, just to really show you that it's actually a fully different map and a different number I'm typing. 8 is gray, gray, gray. So that's twice, two different people aiming to type two different numbers, two different PIN with two different mappings that have been able to do it through the exact same interface. Now what I want to show is this version with a side panel. So we've seen that for the interaction one, the version with the two big buttons of non-colors. And this is the exact same principle as before. That is, for each digit, we have a repetition of the interface. And we are simply going, each time I click on a button, we're simply going to record that on the interface on the right with a tiny dot of the color of the digit we want it to type. So if we want to type 8 using this color pattern, what we do is we look at 8, we pick a gray button, so this one in our mind, and when I'm going to click on it, that's going to put a dot everywhere. So for the digit 8, that's going to put a gray dot here. For the digit 0, this is going to put a yellow dot here. So let's click. As we said, for the digit 0, we have a yellow dot. For the digit A, we have a gray dot. Contrary to the previous version with the two buttons, all of the hypotheses are still active at this stage because, well, the buttons doesn't have any color. So we have nothing to compare this dot to. So, well, it might well be any of them really. So we need to keep going. So the color have changed. 8 is now gray again. So I'm going to use another gray button. And hopefully your expectation should be that I'm going to have a dot in all this top right corner of different color. But because this is the first time I'm clicking on the top right button, nothing again will change in the hypothesis. They will all remain green. And that is what is happening. So now we have still 10 different versions of what the user might be trying to do. The user might be trying to type a 0. In that case, those two buttons are yellow. User might be trying to type a 8. In that case, which is what we do, but the machine doesn't know it. In that case, the two top right buttons are green. 8 is now yellow. I'm going to click on a yellow button. 8 is yellow, and I'm going to click twice. So I re-click on that button, which means that for the first time, we're in the situation where some buttons have received 2 clicks. And that means that some discrepancies, some inconsistencies start to show. For example, for the digit 0, it happened that the first time I clicked on the middle, digit 0 was gray. The second time it was yellow, which means that if the user was trying to type the digit 0, then he would have used the middle button when 0 was gray, and then when 0 was yellow, which means it would have been just the central button to mean both gray and yellow, which is not possible for this interface. And if we look at 2, 3, 7, 6, and 9, it is the same problem. So we can rule 0, 2, 3, 6, 7, and 9 out. I keep typing an 8. And it is yellow, so I'm going to reuse another yellow button, let's say this one. Nothing changes because it's the first click on that button. And then I'm going to click on a gray button for 8. 2 more hypotheses are being ruled out because the clicks are different on the top button. And 2 hypotheses remain valid, which is number 4 and number 8. So for number 4, what we see is that the middle button is used for yellow if we were typing a 4. If we were typing a 4, the top right button will be used for yellow too. And the 2 other buttons will be used for gray. If we were typing an 8, we would be using the 2 top buttons for gray and the 2 below buttons for yellow. It's important to realize that at this stage, both options are as valid. And I could actually switch in my mind and decide that I want to type a 4 with this version. Obviously, this is easy for me because I see that. I can't see it visually, but that would be really hard for a user at this stage to kind of change what they were doing, because they would not be able to track in their mind which digits are still valid and what is a color assigned to them. So anyway, I can continue typing my 8. So 8 is gray. Gray, let's say I can use the top right button. That didn't make enough of a difference. If I continue, 8 is yellow. And that's it. After quite a few clicks this time, so 5 and 3, 8 clicks, only one hypothesis out of the 10 has a consistent color mapping, and that's number 8. And because we know that we're typing number 8, we can put it there, and because we know number 8 is there, then we know that the 2 buttons here are yellow, which we show on the map, on the buttons, and the 2 top buttons are gray, which we show also there. So if we continue, what is happening now is that we have that information available, and we propagate it to all those hypotheses. We duplicate this pad to everybody. And that means that for those buttons, when there is a click, we can revert to the if this then that principle of the first interface when the button were known. For example, if I want to type an 8 again, I look at 8, 8 is yellow. If I click on a button that is already yellow, then we can rule out half of the hypothesis in one go, because one was gray, but I clicked on the yellow button, so it cannot be number 1. So that's the main difference between knowing and not knowing what color is attached to a button. However, if now I continue typing 8 with a button that's not been touched before, you see that this made no changes to what happened before, because this is the first click received by that button, which has no color attached to yet. So I will keep typing an 8 using a mix of known and unknown button. So 3 digits are still possible. 8 is yellow. I'm going to click on a yellow button, and that ruled out the remaining hypothesis, because 5 received a gray, like a yellow click when the digit was gray. And I think that explains the process. We're going to do the same, because we know it's an 8, this is yellow, and those 2 are gray. When I continue, I propagate this there. And if I, let's say, I'm going to type a 2 this time, I look at 2, 2 is yellow, I'm going to do yellow, gray, gray. That ruled out all the hypotheses. So 2 is the digit we are trying to type. I know the color of this square, which is gray, and I continue typing a 2. 2 is gray, so gray, gray, yellow, yellow. And we figured out that the last digit is a 2, and we found out the pattern, and now we are back to the original interface as a pre-calibrated interface. So that's really all there is to this IFTT-PIN principle. But I think what we really want to keep in mind is that this novel approach to this interface is that as a user, instead of coming with only a digit I want to type when I face the interface, I come in front of the interface with a digit I want to type and a way I want to use the interface. So that might be disturbing at first, because we are used to adapt, to be the one that has to adapt to how the interface is defined. But with this kind of self-calibrating interface, we can actually start interacting as we want to with the interface, and it's the interface that will adapt to us. Thank you.